Welcome to the session today to talk a little about some of the opportunities we see in WHIN. I'm Bernie Engel, Associate Dean for Ag Research and Grad Education. And it struck me a couple of months ago when I reached out to Johnny Park, who will be our first speaker here in a few minutes, to talk about an opportunity and a proposal for engaging WHIN and some of the opportunities there. And it really made me start thinking that if I didn't know about this opportunity and didn't see all the places to plug in, then probably most of us were in the same situation. So that's sort of how we get here today. So Johnny Park from WHIN will be first up, sharing a bit about WHIN in the community in the 10-county region. Dennis Buckmaster and Andrew Balmos will be up next with some of the WHIN efforts at Purdue, and then Brad Joyce will close out presentations with a bit on some of the funding opportunities that he sees. We will make the slides available. We'll make those available after the session today. We are recording. There were several people who wanted to be here that could not make it, so we're recording to be able to share some of this with them. The other thing I would remind you, if you have questions during the talk or as we get toward the end of talks, please type those into the chat and I will sort and read those at the end as we have time for some questions. So Johnny, without further ado, let me let you go ahead and share your screen. So Johnny leads the ag part of WHIN efforts here in the community and beyond. And so Johnny will share some of the many great things going there. And again, it seems like a great opportunity to learn some more today. So Johnny.
Thank you, Bernie. Can everybody hear me and see the screen? Awesome, thank you. All right, again, my name is Johnny Park. I am the CEO of WHIN. WHIN stands for Wabash Heartland Innovation Network. Thank you for joining us. So today, my goal is to really let you aware of various ways that you can leverage the WHIN Living Lab assets that we're building in our region. Oh. So about 3.5 years ago, Lilly Endowment donated close to $40 million to this region to WHIN, which is incredible a gift. And these are the 10 counties that we're focusing on in our initiative. And today I want to talk about the Living Lab, which is really the main focus of this initiative. So everything that we do, we have lots of activities that we do out of WHIN, but it boils down to a single strategic framework. And our goal is to develop this 10-county region as a very large-scale living laboratory for innovative IoT technologies. So it's about 90 miles by 72 miles. Again, those are the 10 counties that you saw in our region. So in order to accelerate the Living Lab development, the WHIN Alliance was really the program that we devised to build this Living Lab. Essentially, the model works this way. So WHIN as an organization, we talk to and engages with lots of technology companies out there, and we vet those technologies that are viable and innovative, that are good for our farmers and manufacturers in our region. So then we partner with those companies, and once identified and vetted, then we work with those tech partners to introduce and implement and adopt those technologies by our farmers and manufacturers. Okay, but what's really unique about this model is that we also want to engage very meaningfully the researchers as yourselves in this ecosystem. So as we implement these technologies in farms and manufacturing facilities, we have access to this data. So that's by agreement, and we can aggregate it and make it available for research and education purposes. So that's one of the ways that we are also engaging the research community in this ecosystem. So again, I want to kind of touch on several ways, but mainly 4 ways that I believe that you will be able to leverage the Living Lab assets for your research to make your future grant proposals more competitive. The first is accessing this data, this incredibly valuable real-world data that's coming out of real operations in farms and manufacturing facilities in our region. So weather stations is an example. So we have about 160 weather stations that are deployed in our 10-county region. These are widely used Davis station. You can see some examples in the pictures. Some are in public spaces like pedestrian bridge, but most of them are deployed in real farms. So you can see on the right, so those are locations, rough locations of the weather stations in the 10-county region. And as I mentioned, these are Davis weather station. And so you could see exact model numbers. And what was really important for us is that we wanted to make all these sensors consistent. So if you're aware, Coal Alliance is a large retailer that has a pretty big presence in our region. They already had about 90 weather stations. So again, these are commercially already utilized, well utilized in our region. And so we deployed additional 70 weather stations on top of that. So then making a total of 160. And WHIN and Coal Alliance have an agreement to be able to share data with each other so that we can use it for research and education purposes. So each weather station, as you can imagine, has various sensors, temperature, humidity, pressure, wind speed, direction, a rain gauge, but also has soil moisture and temperature at 4 different depths, 2 inches, 5 inches, 10 inches, and 15 inches. And of course, it's also equipped with solar radiation as well. The next set of data set is intelligent imagery. So these are high resolution fixed wing imagery. And so to kind of give you a sense, I'm sure many of you have heard about drone imagery or satellite imagery. A fixed wing is sort of kind of in the middle as far as the resolution is concerned, and also as far as the cost is concerned. A satellite image, probably the most high resolution you can get these days is about 3 meters by 3 meters. Drone, you could probably get to sub-centimeters, but it's pretty costly. But fixed wing is fairly high resolution, 8 to 10 centimeters, but the cost is very reasonable. So we believe that this is, at least in the near future, a good strategy for farmers that are going to use imagery in their operations. So it's got RGB, 3 channels, and then a near infrared, and also it's got thermal, which is makes about 5 bands in the image. We flew over 600,000 acres. So you could see in the red box, those are grids that were flown in the 10-county region. So here's some examples of RGB, near infrared, and thermal image. But what's also interesting about this data set is that it actually flies 13 times across entire season. So you could see that it flies once before planted. Between May and July, they fly every week, about 7 flights. And between August and October, they fly about every other week. So lots of great data throughout the entire season with this data set. Here's an example of another data set that we're collecting, Solum Tech. Some of you might have heard of this company. So they have an IoT device that goes into a farm ag equipment, and it logs its GPS and type of equipment, what it's doing currently, whether it's spraying or tilling or moving, its equipment conditions, as well as local weather conditions. So it's a very, very a rich data set that you can get out of these ag equipment. And the application for this particular solution is to give farmers a real-time logistics information so that they can operate their ag equipment more efficiently. So again, so those are some examples of the data set that we have. Again, these are commercial solutions that we have vetted, and they are being applied in real farms. All that data is aggregated and made available in data portal. So if you go to data.whin.org, you'll be able to create an account and see some sample data sets that I just showed it to you. So today, the WHIN weather station network data, so these are 160 weather stations. As I mentioned, every 15 minutes they collect the data, and a 600,000 acre of high resolution 5N aerial imagery is available today. And the ag equipment data that you saw from Solemn Tech and other IoT sensors that we deployed in manufacturing facilities will be available soon. So we really see three types of usage, three cases. If you want to use the data for education purposes or class projects or your lectures, it's entirely free. We also have, like I said, sample data set that you can use for research. So if you want to create preliminary results for grant proposals or your papers, that is certainly free. But what we ask is that if you get a grant that will utilize the data entirely or fully, there's a paid license version. And what we envision is that this will be as a line item expense in your research grant proposals. We want to make this as easy as possible for you as a professor, as a researcher, to license this data. So as we speak, we are at the very end of finalizing this pre-approved template, so that as a professor, as a researcher, as you are writing a grant proposal, there is already a pre-approved form ready for you to easily sign. And when the grant gets funded, then the licensing can be done very easily and frictionless. Okay, so second way that we believe that you'll be able to leverage the Living Lab assets for your research is the connectivity infrastructure. So in addition to data that you saw, we're building a really incredible connectivity infrastructure in our 10-county region. As you may have heard, we are going to deploy an aerostat. This is the first aerostat that will be deployed in our nation for telecommunications purposes. Not only can be used for broadband purposes, but also it has a way to connect sensors. So it's a tethered balloon, if you will, and the fiber goes up to the balloon, and because of its height, which flies at about 2,000 feet in the air, with a payload of about 300 pounds, you can actually have multiple antennas on the aerostat. So for sensor connectivity, we expect to have about 50-mile radius coverage for LoRaWAN, which is a pretty popular sensor connectivity network. In addition to that, we also are going to deploy a ground level gateway so that there is a sufficient coverage, not only from the aerostat's perspective, but also from the ground level. So we want to make sure that our 10-county region is fully covered, where you can easily deploy low bandwidth sensors using our network. Third way that we believe you can utilize the WHIN Living Lab assets is really utilizing the staff, right? So we really believe that this 10-county-wide Living Lab can truly enable novel and innovative research projects that really can bring the lab prototypes into the real world settings to further validate the research. But those projects often require lots of activities that are outside your core expertise and research. So the WHIN staff can help such activities so that you can focus on your core research while fully leveraging the Living Lab assets. So if you need to access those the connectivity infrastructure that I mentioned, we can help. If you need help in implementing your sensors or your technologies in real farms, we can help. In fact, the third, the senior IoT solutions engineer position that you see we're about to hire a person, that position was specifically created for that purpose, that we want to be able to help professors who have some sensors that want to deploy in our region, that person can be utilized to do so. In addition, if the research project emphasizes on commercialization of the project, which I believe many agencies would like to see the technology being commercialized, we can help with that too. Many of us have extensive experience in startup, so we can certainly support and help fostering commercialization of your technologies. So finally, is to really engage at the ability to engage with tech partners and progressive farmers in our network, in our region. So farmers, so this network currently has 35 very progressive farmers that farm about 140,000 acres of corn and soybeans. So these are not your average farmers. These are very progressively minded who are adopting these technologies in their own operations. And oftentimes, they are the most influential farmers in the region. So we're continuing to build this network, increasing the number of members in our network. So if you need to work directly with farmers, we can certainly facilitate that relationship. And equally importantly, these tech partners, so these are commercial partners that we partner with to introduce their products in our region. And many of them actually have desire and have track record of working with university partners to develop their next generation products. So it'll be a great opportunity for researchers like yourselves to find a partner as a tech partner to further and advance the research. I'm not going to go into details of each of these partners, but there are some more tech partners that we're currently vetting that would be of interest for you. Again, I'm only showing the tech partners in ag sector. And so, but we are also vetting several more in currently. So that's all I had. Hopefully I kind of gave you a quick overview of how you'll be able to leverage. Again, our ultimate goal is for you to have a compelling research proposal that is competitive and fully utilize the WHIN Living Lab, and that's part of the ecosystem we're trying to build in this region. So that's all I had. And if you have any questions, happy to, I don't know if you have some time to do a quick Q&A, Bernie.
Johnny, thanks. Yeah, it looks like there were a couple of questions that had gotten started. Song Lin had asked about if it included forestry with your imagery, and it looks like Zach has responded. You want to say just a little more about how much area you are capturing, Johnny, with the imagery, and again, plans going forward for that?
Sure. So those are driven mainly by the farmer subscribers, right? So because the IntelliNair, our tech partner, is servicing the farms who actually pay for their services. But in order to cover their farms, they actually have to fly a pretty large grid, and oftentimes it does include other non-farm areas. So like I mentioned, our entire members only cover a little over 140,000 acres, but they had to fly 600,000 acres to cover those. So they actually fly a lot more larger areas than actual farms, and oftentimes includes, forest, forested areas. And I don't know to what extent that we do that in our 10-county region, but if you're interested, we can certainly give you the exact map, and you can take a look at where it is imaged.
Thanks. Looks like from Jeff Valenick, there was a question about data set versioning and DOIs, and looks like Zach has got that addressed. Jeff, was there anything further that you needed to follow up on there?
No, I think it's just, from my perspective, Bernie, it's wonderful to have data and access to data, Johnny, so it's fantastic. Thank you. I think one thing that people downstream who use the data will need to have some certainty that there's not drift in the data sets as more data is added to them or edits are made. I think that's something that PUR has offered, where you can publish through the Purdue University Research Repository a data set, it's given a DOI, and then that's it. It's like a published work. And then when other people do other work with the data sets to complement or compare to the work you might have done yourself, they're using the exact same data. It's a certainty in the data is all I wanted to surface. It's important.
Yeah, great comment. Yeah, we can certainly work, with you. We're just rolling this out, and as the need arises, we can certainly make those happen.
And looks like a question from John Jen about ground truth data. So is there any ground truth data that corresponds to the airborne images?
We do not have any ground truth data.
So maybe I can make a comment, Johnny.
Sure.
Hi guys, Jack Stuckey from WHIN. So one of the notions is that if you're going to do some research and you work with a particular grower or a couple growers, is that you kind of form a tight loop with them, and so you would work with them to get access to their soil sampling or to your own soil sampling or other kind of ground truthing as part of that research project. In some cases, the growers might have an integration into like John Deere Operations Center, and you might have some application notes and some other things. But the idea is that this would be the IntelliNair imagery would be like a complementary to any additional kind of integrated research where you need multiple levels of data, multiple layers.
Thank you.
Thanks, Jack. All right, Johnny and colleagues, thanks. We should probably move on to the next presentation. I know you'll continue to be on, and we'll make sure that you'll have information if you do need to catch up with some of the group on the call and vice versa, that will be available. So next up, Dennis Buckmaster. Dennis, I assume you will introduce Andrew, and I think you've got the first couple of slides that you'll want to present and go from there. Thanks.
Very good. I think my internet connection instantly got better, so I'll try my video on. Andrew's going to share the slides just in case my connection is poor. I'm Dennis Buckmaster, a professor in Ag and Biological Engineering, and also serve our deans and all of you as a Dean's Fellow for Digital Agriculture. And in our case, speaking for me and Andrew here today, we aren't so much in the position of having data that you might want to access, but it's really more about the data pipeline that we can facilitate that was very largely WHIN funded and WHIN supported, so from the Lilly Endowment Foundation. So you can go to the next slide. So I'll just make a couple of introductory comments, and then Andrew can speak to some of the specifics. But in the original WHIN proposal, when they spoke of the test bed, they were really speaking of the Agronomy Center for Research and Education, ACRE, and the new Ag and Biological Engineering building. In particular, the high capacity data pipeline going from the ICSC, the Indiana Corn and Soybean Innovation Center, and campus and the rest of the world, what came from WHIN funds out of the Lilly Endowment. Also, a good dose of funds from that went to the new ABE building. And I'm happy to report that we moved in there last week and we're sort of occupying it this week. But in that building are several facilities, a sensor test bed, a few maker spaces, part of the high bay area, robotics lab, etc. And those are part of the test beds of Internet of Things for advancing agriculture. But since that time, we also have expanded this work a little bit into the Animal Science Research and Education Center, primarily the farm operations, but now also looking into some of the livestock units. TPAC, our nearest Purdue Ag Center, just south of campus. We've done some work there, and then we'll also connect to the other centers across the state. So in this work, it's not certainly not me. These are the kinds of things that are the people that I know. But for example, Ag IT was very instrumental in the connectivity piece to Acre. And then now Aaron Waltz in Ag Data Services. If you do not know Aaron, you certainly should reach out to him as we're growing this data ecosystem and sort of the talent pool around data architectures and data pipelines as well as analytics. Aaron is a very good key point person for you to meet. All right, so next slide. One of the early things, as I mentioned, use of the WHIN funds was to connect the Purdue Acre farm, agronomy farm, to the rest of the world with the high capacity pipeline. Then also Ag IT installed Wi-Fi and LoRa at Acre. And then now we're in this sort of step 3, the infrastructure for analytics. So with that as a very quick overview, I just do want to give thanks and credit where it's due. The likes of Jim Beatty and certainly Ron Turco as head of agronomy, Jeff Fields out at ASREC. They have been just wonderful to work with in terms of, as long as we don't get in the way and slow them down, they have just been very helpful and willing to just let us put some things in vehicles, et cetera, to do some testing. And Andrew can speak to that. So that's sort of my quick overview. And that is that in this group called the WHIN Ag Group and beyond, in part the OAT Center, the Open Ag Technology and Systems Center, faculty and staff, we have the wherewithal to help you with your data pipeline needs. And so with that, I'll just introduce Andrew, who is a PhD candidate in electrical and computer engineering, but we've hired him using the WHIN funds at Purdue as a data and a software engineer. So officially he reports to Bernie in ag research and graduate education, but it's sort of through me and certainly in close collaboration with me and Bruce Erickson, John Scott, Shamali Chatterjee, and some others in the WHIN Ag Group. So I'll let Andrew take it over from here, speaking to some specifics of the kinds of facilities and capacities that we have for data pipeline in the region.
Thank you. So well, there's a couple of major sort of projects that we're doing out, primarily Acre, but like Dennis mentioned, we've done some stuff at ASREC as well too. But from a pipeline perspective, we're really looking at kind of sensor deployments and how do we use some of these technologies. And one of the goals is to try to deploy them in a way that looks a lot like you might deploy on a real farm. So of course, there's always this sort of pull. It's like what researchers need oftentimes to conduct research sometimes looks a little bit different than what growers need to practice. So we're trying to evaluate sort of both sides of it. So in this case, what we're deployed is Farm Beats research project, which is Microsoft-driven hardware and Azure cloud backend sort of data processing software. And the Farm Beats sensor box is right here. And this is really just a box that you can hook a variety of different sensors like temperature sensors, soil moisture, things like that to it. And it samples it a couple times a minute at the fastest. So you can even do it like say once a day, depending on your needs. and it sends it back to the cloud over LoRa. And it's a custom LoRa link, but in the application we're doing right now, we're putting sensors out at the gantry, out at Acre, and so there'll be some sensor boxes located out in this field here, and the LoRa link just goes back to the Indiana corn and soybean building. And the base station is this box here. It looks like it's called the Sub Edge by Microsoft, and it's really just essentially a LoRa radio and a little computer connected to the internet. And all it does is process the LoRa radio and send the data up to Azure. The rest of it happens in the cloud, and Microsoft kind of has a scheme to bring that data in, process it, and do different things with it. But we're primarily interested in understanding this LoRa link and how can we use it to backhaul sensor data. One of the things that we're sort of doing moving forward with it is converting it to LoRaWAN instead of just a proprietary LoRa thing that Microsoft created. And here we're leveraging Ag IT's LoRaWAN deployment out at the farms at Acre. It's on the tower. And so their one gateway that Ag IT has deployed covers Acre and Azarec and really even beyond that. And what we've successfully been able to convert this sort of proprietary sensor box to the open standard LoRaWAN, and we move the data back through sort of Purdue-owned technology. And here we can now kind of split the data. We can send the data to Azure like originally designed, so that sort of farm beat still works if that's the way you wanted to process the data. Or for example, we could flip it on or push it on to a sort of a data pipeline that Ag IT and Aaron Waltz's group is working on to do sort of that type of processing, storing, analyzing, and sharing here all on campus. And so it's just an example of one of our real deploys out there where we're able to kind of take commercial hardware and work with it and massage it into different backends depending on what your goals are. One of the other things that we're working on is TV white spaces. So we're interested in using LoRa as a backhaul, and just for reference, LoRa is good for things like sensors, things that send a couple of measurements a day or maybe a couple of measurements an hour. You're not going to be able to push video signals through it or something like that, right? It's pretty low rate, but very long range. TV white spaces comes in and has a similar performance metric in that long range. You can get kind of several kilometers, but it has high rate with also high power. So you need to have good power sources on both ends, but you can cover long distances and push large data. And so then people took that technology and sort of split it in two and said, well, if we do what we call a narrow band, we can lower the power needs. We also sort of lowered the data rate, and it's not quite as low as LoRa, but it's got power in the range of LoRa. So one half of TV white spaces is this TV white space narrow band, and it's really for sensor data and not big data. And we're working on deploying that as we speak. Again, this is a Microsoft project. They're the ones that created the hardware. They're also the kind of primary pushers of the FCC to make this allowable. And so the next step will be to take their radio and integrate that narrowband thing into the Oat Center's ISOBLUE, which is a machine telematics unit. And we're going to deploy them at Acre, and we'll use TV white spaces to bring back some machine data like maybe position or if there's currently an error on the bus, things like that. This requires an FCC license to do, and we have that now granted to us, which is nice. So if you're doing any sort of TV, if you think TV white spaces might be a useful tool in your research, we kind of have the license to operate within. So that solves a lot of the headache involved in deploying that. And then lastly, and it's kind of on the radar, not necessarily in works yet, is to deploy the other side of TV white spaces, which is the wideband stuff. And this really is about backhauling. It's really about moving larger data over long distances. So maybe you have, maybe you're trying to move your full machine data stream from the field back to your farm where you have internet. So something large, or maybe there's video cameras even on the machines doing some sort of image processing to optimize the metric or something like that. We can actually move, maybe even multiple video streams over TV white spaces. But this is a totally commercially available, completely allowed by the FCC right now product. So it's more about just deploying it. But in our case, we're going to probably deploy it to really learn more about it and figure out, well, really, how does this fit in the ag problems, and how does it help solve broadband? And so that's kind of on the to-do list. So if that feels like something that might fit into your research, there might be a good way to collaborate there too, and have some real research data moving over our sort of test things. So I think with that, that's all I really have to say, except that I'm happy to answer some questions as well.
Thanks, Andrew. So yes, please unmute yourself if you have a question for Andrew or Dennis, or type it in the chat box. We do have time for a couple of questions.
If there are no questions, this might be a good time for Aaron to give a quick introduction of himself and the capacity of his group.
Yeah, Aaron, do you mind doing that?
Sure, happy to. Thanks, Dennis and Bernie. So as many of you know, the Ag Data Services team is a new organization that's a joint effort between Ag Research and Graduate Education and Ag IT. And we're really here to help researchers with their data needs, whether that's data stewardship, analytics, data pipelines. We work closely with Andrew and Dennis and others, as they mentioned. There's a lot of aspects of this that we're seeing some patterns emerge as we work with more teams across campus, and especially within the College of Agriculture here. So one of the things that we can help do is identify what some of those roadmaps are in terms of meeting your research needs with respect to the data side of that, and seeing where there are opportunities to collaborate. This is definitely something that no one team or group can do alone, as you've heard from all of our presenters today. So we try to work in a very collaborative way and help identify who some of those partners might be as well. And I'll put my contact information, my email in the chat in case you'd like to get a hold of me, and we're happy to meet with folks and talk more.
Thanks, Aaron.